proofs. So this will be the first lesson that we begin to talk about proofs. So we're going to start with this diagram right here, which is very familiar. We have some parallel lines right here cut by this transversal with some angles 1, 2, and 3 labeled. So first off, we're given that the measure of angle 1 is 40. So I'm going to go over here and put in 40 for angle 1. And they want to know what is the measure of angle 2 and then justify. So thinking back to parallel lines cut by this transversal, if angle 1 is 40, then angle 2 must also be 40. And now we know this because angle 1 and angle 2 are corresponding angles. So the measure of angle 1 has to equal the measure of angle 2 because they are corresponding angles and are equal. Right? So since the parallel lines were cut by a transversal, we know that the corresponding angles must then be equal. Okay, so now it says here, how can the measure of angle 2 help determine the measure of angle 3? Well, if we know the measure of angle 2, we then certainly know the measure of angle 3, because angle 2 and angle 3 are vertical angles, and they're also equal. So since the measure of angle 2 and the measure of angle 2 must equal the measure of angle 3 because they are vertical angles and they are equal. So now we know that that is also 40 right there. Okay, so what we're going to do is we're going to now kind of get into what proofs are and the different terminologies that we're going to use along with proofs. Okay, so first let's just take a look at what we have here. What we have here are postulates and theorems. So a postulate is a statement that we accept without proof. So for instance, if I say the sky is blue, you've accepted that. We don't have to prove it. A theorem is a statement that's proved by deductive reasoning. Now, deductive reasoning is something that you use. So basically, you're given all of these different statements, and you use your knowledge to come up with a bigger reason. So again, a postulate, we just accept it without proof, almost kind of like saying 1 + 1 = 2, right? But then a theorem is like Pythagorean Theorem. That was proved using deductive reasoning, right? Someone back in the day, they said, oh, hey, look, we have a right triangle. That these two sides, the sum of them squared is equal to the third side squared. I'll put this link up on the Google Classroom. You can kind of click it. It goes through deductive reasoning as well. Okay, so the first one is called the reflexive property of equality. This one is huge. We use this so much. So the reflexive property of equality simply states a quantity is equal to itself. So something as simple as 5 = 5. That's true, right? 5 = 5. Any quantity is equal to itself. But we could also say something like segment BC is equal to segment BC. Whatever BC is somewhere else as well. So take a look at what we have here. We have here that BD is congruent to BD. So if I move this over here, how do you know you have the reflexive property? So if you take a look at what we're actually given here, we have triangle ABD. And then we have triangle CBD. And what do both triangles share? Well, they both share this side BD. So if I were to take these triangles and pull them apart, you would see that BD is here, and it's also right here, and in its entirety, meaning the entire length of BD is repeated twice. It's part of the triangle on the left and the triangle on the right. That's known as the reflexive property. When something is equal to itself, it's part of two different shapes, but it's the same exact length. We mark the reflexive property with an X. So you know how we do like tick marks to show side lengths? If you have the reflexive property, you mark it with an X. As so. That shows that it is congruent to itself. Okay, moving on. Something called the transitive property of equality. Now this is interesting. This says quantities equal to the same quantity are equal to each other. So I like to think of this in terms of heights. So if I'm the same height as Mr. Bronze, and I'm also the same height as Mr. Capel, well then Mr. Capel and Mr. Bronze must also be the same height. Why? Well, they were both the same height to me, so they must be the same height to each other. Now this works in terms of math. Think about this. The measure of angle A equals the measure of angle B. Okay, we know that's true because they're vertical angles. Measure of angle B equals measure of angle A also equals the measure of angle C. So notice they're both equal to the measure of angle A. Right? They're both equal to the measure of angle A. That means that they're equal to each other. So here I would write the measure of angle B equals the measure of angle C. Now we actually know this is true, right? Because A and B are vertical angles, and then A and C are corresponding angles. Right? But B and C are alternate interior angles. So that's kind of how you use the transitive property. Oops, just undo this. There you go. And now notice the order is important. Since angle A is equal to angle B and angle A is equal to angle C, then we must state that angle B is equal to angle C in that exact order. Okay? So for transitive property, order matters. Now, there's one that's very similar to the transitive property, and it's one that you've done a bunch of times, and that's the substitution postulate. Right, so substitution, like in anything, you take something out and you put something in. You put in its equal. So take a look at the substitution postulate that we have here. A quantity can be substituted for its equal in any statement of equality. Remember, this is a video. You could always pause and copy. So basically, take a look at what we have. A plus B equals 180, right? Here it is. They're a linear pair. Measure of angle B equals the measure of angle C. They're vertical angles. So what do I substitute? So how do you do the substitution? You look to see what is repeating. So that's the measure of angle B. Then you take out the measure of angle B and you substitute in its equal, which is the measure of angle C. So now this reads the measure of angle A plus measure of angle C equals 180. Okay, so here we have it. Okay, so again, you take this out, you plug this in. And we also know A plus C equals 180 because they're a linear pair. So one thing that you want to see is right here, Z equals Y and Y equals X. So two things can happen. You could either use transitive or substitution. Here's the key thing. Substitution always wins. So I would always go with substitution. Mr. Bronze, Mr. Capel, they'll tell you the same thing. Just stay safe with substitution because transitive property, the order matters. So here, let's try to use substitution. For substitution, you look to see what repeats. Y repeats. Okay, so I'm going to take out this Y and replace it with its equal, which would be X. So what do we have? the measure of angle Z equals the measure of angle X. Substitution always wins. Okay. So now going back, we can figure out how we had the alternate exterior angle proof from before. We said angle 1 is congruent to angle 2 because corresponding angles are congruent. We then said angle 2 is congruent to angle 3 because vertical angles are congruent. And then finally, angle 1 is congruent to angle 3 not because they're alternate exterior angles, but take a look. 1 is congruent to 2. 2 is congruent to 3. We're going to substitute, right? We're going to say angle 2 repeats, so we're going to plug in angle 3. So again, it could be substitution or transitive, but we always like substitution. Okay? And that's the first day of proofs. Very basic. It's things that we've done. We've talked about vertical angles, corresponding angles, substitution, so on and so forth. There is a practice that you want to try. And we will begin proofs day 2 on Monday. Have any questions, please reach out.